Hello, my dear friends. How are you? Hope you're fine. What about your studies? Study well. Keep going. Okay, today we are continuing the chapter surface chemistry. We have already discussed the introduction part. Today we are continuing the chapter from characteristics of physical and chemical adsorption. Okay, we started the physical properties, that is the characteristics of physical adsorption. Okay, what are they? Yes, one is lack of specificity. Okay, the characteristics of physical absorption is that what is? Yes, it lacks in the lack of specificity. Okay, for a given surface of an adsorbent, it does not show any preference for a particular gas. Okay, a given surface of an adsorbent does not show any preference for a particular gas. Okay, got it. Next, nature of adsorbate. Okay, the amount of gas adsorbed depends on the nature of gas. The amount of gas adsorbed depend on the nature of gas. Okay, and next point, and as a point for this is easily liquefiable gases are readily adsorbed. Easily liquefiable gases are readily adsorbed. Okay, let we can move to the third point. Okay, the first two points are we discussed in our previous discussion. Today we are moving to the third point, that is reversible nature. The physical adsorption or physisorption is a reversible process. We know that what? Yes, the physical adsorption is the force is van der Waals force of attraction. Okay, in reversible force, in physical adsorption, the bond is reversible nature. Okay, and it have here the pressure has an role. What is the role? More gas is adsorbed when the pressure is increased. There is a direct relationship between pressure and gas adsorption, physical adsorption. When the pressure is increased, more gas is adsorbed. Okay, then on the reverse, what will happen? When the pressure is decreased, what will happen? The gas can be removed. Okay, we already said that adsorption is an exothermic process. Okay, adsorption is an exothermic process. So what will happen? Hence, physisorption increases at low temperature. Adsorption is an exothermic process, and hence physisorption increases at a low temperature and decreases with the increasing of temperature. Physisorption decreases with the increase of temperature. When temperature is increased, physisorption decreases. Okay, then move to the next point. It is about the surface area. Okay, what will happen if the difference in surface area? What will happen? The surface area, there is a relation. That is, when surface area increases, what will happen? Adsorption also increases. When surface area increases, adsorption also increases. Okay, what a point. Then come to next point, enthalpy of adsorption. Okay, enthalpy of adsorption. For physisorption, enthalpy of adsorption is low. Why? Because the attraction between the gas molecules and solid is only due to weak van der Waals force of attraction. Okay, the enthalpy of adsorption is low in physisorption because the attracting force in physisorption is only weak van der Waals force of attraction. So this is the case of physical adsorption, and these are the characteristics of physical absorption. These are very important points. Study well. Okay, next we move to the next adsorption, that is chemisorption. What is the properties characteristics of chemisorption? Yes, first point is, on contrary to physical adsorption, chemisorption is show high specificity. First point, chemisorption shows high specificity. Okay, what is high specificity means? Yes, In chemisorption, there is a possibility or there is a formation of a bond between the adsorbent and adsorbate. Okay, so the chemisorption occurs only if there is a possibility of chemical bonding between the adsorbent and adsorbate. Chemical bonding between adsorbent and adsorbate if is occur in chemisorption, that is high specificity. Then irreversibility. What is irreversibility? Chemisorption involves what? A compound formation. So chemisorption is irreversible nature. A chemical compound is formed, so it is irreversible character is low. So no irreversible character. Okay. And next point is that chemisorption is exothermic process. Chemisorption is an exothermic process, but the process is very low at low temperature. Okay. Chemisorption exothermic process, but the process is very slow at low temperature. Okay. And we also already discussed about the change of physical adsorption to chemical adsorption. Here we can once again say that physisorption of a gas or of a adsorbed or the gas adsorbed by physisorption at a low temperature. When a gas adsorbed by physisorption in low temperature can change to chemical adsorption when at a higher temperature. Okay. And in the physical adsorption we said that a pressure is very helpful for physical adsorption. Here also the physical adsorption, in the chemical adsorption also the pressure is helpful. So when pressure increases, chemical adsorption also increases. Okay. As in the case of physical adsorption, here also the surface area, chemical adsorption increases with the increase in the surface area of adsorbent. Chemical adsorption increases with the increase in the surface area of the adsorbent. Okay. What is enthalpy of adsorption of chemical adsorption? The next point is enthalpy of adsorption. What is enthalpy of chemical adsorption? Is high. Why? It involves the chemical bond formation. It involves the chemical bond formation. Okay. In the physisorption, there is a possibility of formation of more than one layer on the adsorbent surface. There is a possibility of more than one layer on the adsorbent surface. But in the case of chemisorption, there is a bond formation, chemical compound formation, there is a unimolecular layer. Okay, these are the difference between physical adsorption and chemical adsorption. It is in the exam point of view, it is very important, so study well. Okay, next we move to another point, that is adsorption isotherm. Adsorption isotherm. From the name itself you may identify what is adsorption isotherm. Adsorption isotherm shows the way it is a curve or a graph. What? The variation in the amount of gas adsorbed by the adsorbent with pressure at a constant temperature. Okay, and it can be expressed by a curved termed as adsorption isotherm. Okay, that is adsorption isotherm. Next we are moving to Freundlich adsorption isotherm. Freundlich adsorption isotherm. Very important point, Freundlich adsorption isotherm. It gives an empirical relationship between the quantity of gas adsorbed by unit mass of a solid adsorbent and pressure at a particular temperature. Freundlich adsorption isotherm gives a relation between the quantity of gas adsorbed and pressure at a particular temperature. That is, Freundlich gives an equation, that is x by m is equal to k into p raised to 1 by n. x by m is equal to k into p raised to 1 by n. Okay, where x is mass of gas adsorbed. X is mass of gas adsorbed. M, what is m? Mass of adsorbent. M is mass of adsorbent. Okay, and p, what is p? Pressure. And k and n are constants. K and n are constants. Okay, and what is the properties of these constants? Which depend on the nature of adsorbent and the gas at a particular temperature. The constants depends on the nature of adsorbent. That is, if we take different gases, the value of k and n can be changed. Okay, here an important property is that the temperature must be constant. Okay, from this isotherm we can see that there is a decrease in the physical adsorption with the increase in temperature. Okay, that is, there is a decrease in physical adsorption with increase in temperature, and this curve seems to approach a saturation at a high pressure. Okay, the curves always seem to approach a saturation at a high pressure. If we take the logarithm of this equation, x by m is equal to k into p raised to 1 by n, we can see that log x by m is equal to log k plus 1 by n into log p. Log x by m is equal to log k plus 1 by n into log p. Okay, the validity of Freundlich isotherm, how can we verify? For a gas, how we can verify the validity of a Freundlich isotherm? Yes, we can plot a graph log x by m versus log p is in the form of a Steiner equation. Log x by m versus log p. What is the case? What will be the result? What should be the result? Yes, if it comes to be a straight line, the Freundlich isotherm is valid. If it comes to be a straight line, so if we plotting log x by m versus log p, if we get a straight line, the Freundlich absorption is valid and is verified for that particular gas at a particular temperature. Okay, from the graph we can calculate the slope of this line, that is 1 by n. From the graph we can calculate the slope of the line, that is 1 by n, and y-intercept is log k. The value of 1 by n varies between 0 and 1. Okay, the values, the 1 by n can have the values between 0 and 1. Okay, what will happen if the 1 by n is 0 and 1 by n is 1? What is the condition it indicate? If 1 by n is equal to 0, then x by m is equal to a constant. Then we can conclude that the adsorption is independent of pressure. Okay, what is the case if 1 by n is equal to 1? If 1 by n is equal to 1, it indicates that x by m is equal to kp. What does indicate? The adsorption varies directly with pressure. That is, in if 0, the adsorption the pressure have no role, and if it's 1, that is, there is a direct relation. As the pressure increases, adsorption increases. Pressure decreases, adsorption decreases. Okay, and the experimental isotherm always seem to approach saturation at high pressure. If too much pressure is applied, the isotherm always seem to a saturation. Okay, that is, it cannot explain Freundlich isotherm where in the case of high pressure. Okay, it is a small limitation of Freundlich adsorption isotherm that Freundlich isotherm fails at a high pressure. Okay, it is the case of Freundlich adsorption isotherm. Got the point? Okay, let we can move to the next point, that is adsorption from solutions. Adsorption from solutions. What is the case adsorption from solution? Can you give an example? Like a solids, the solutions have the capacity to, the solution phase also have the capacity to what? Yes, the solids can adsorb solute from the solutions. Solids can absorb solutes from solutions. Okay, for this we can consider an example. Okay, if we take some charcoal and a mixture of water and acetic acid, to the mixture we add some charcoal and calculate its strength or concentration before and after adding the charcoal. You can see that the concentration of acid decreases when charcoal is added. Okay, it is an example of adsorption from solution. Okay, and another example is that when shaking of litmus solution, we know that what is litmus solution, litmus paper. Okay, so when litmus paper or litmus solution is shaking with the charcoal, the solution become colorless. What happened is there is an adsorption of color by the charcoal. Okay, what the point? And we can check some of the properties of adsorption from solution one by one. Okay, the first point is that the extent of adsorption for the case of solution decreases with an increase in temperature. So when the temperature is increased in the case of solution, from solution the adsorption decreases. The extent of adsorption decreases with an increase in temperature. Okay, second point is that the extent of adsorption increases with an increase of surface area of the adsorbent. It is very clear point. That is what is the case as the surface area increases, adsorption increases. That is extent of adsorption increases with an increase of surface area of the adsorbent. Okay, and third point, the extent of adsorption depends on the concentration of solute in the solution. Extent of adsorption depends on the concentration of solute in the solution. That is, there is a linear relation. Solute increases, the adsorption also increases. Okay, and next point, the extent of adsorption depends on the nature of adsorbent and the adsorbate. Extent of adsorption depends on the nature of adsorbent and adsorbate. Okay, got the point? From the solution, the Freundlich equation can be rearranged, or there is a small change in the parameters. So from the solution, the Freundlich equation can be expressed as x by m is equal to k into c raised to 1 by n. X by m is equal to k into c raised to 1 by n. Here we used the term concentration instead of pressure. Why we used concentration? Yes, here in solution phase the concentration is more significant than pressure. Okay, then we take the logarithm. We can see that log x by m is equal to log k plus 1 by n into log c. Log x by m is equal to log k plus 1 by n into log c. Okay, as in the previous case, we can also verify the Freundlich isotherm by plotting a graph between log x by m versus log c. what will happen if we draw a graph, putting a graph between log x by m versus log z? What will happen? Yes, it will give a straight line graph. If we get a straight line graph, the Freundlich isosome is verified. Okay, so this is the case of the adsorption from solution, and we discussed the chemical adsorption, physical adsorption from solution. Okay, then we can go to some applications of adsorption. Some applications of adsorption where we can see some adsorption. Okay, the first point is that it is used for the production of high vacuum. The phenomenon of adsorption can be used for the production of high vacuum. We know what is vacuum. So the water molecules can be removed and the particles can be removed by using adsorption for the production of vacuum. Okay, and the second one is for the preparation of gas mask. For example, charcoal mask. Okay, and these masks are used for in mining to coal mines to avoid the contact with the inhale of poisonous gases. Today we know that what is the use of mask in our day-to-day life. Today government give a strict instruction to wear mask in this time of corona. So second use of adsorption is that for the preparation of gas mask. Okay, and third property is that for control humidity. Okay, for control humidity, and we here using the silica aluminum gels are used as adsorbent. Okay, and the next point is that here we already discussed about the removal of color from matter solution, that is removal of coloring matter from solutions. Okay, and the fifth point is it is used as a heterogeneous catalyst, used in heterogeneous catalysis. Okay, what is the case? Here we can take an example, that is in the case of ammonia preparation. In the case of ammonia preparation, what is the case? Yes, iron is used as a catalyst, and in the hydrogenation, nickel is used as the catalyst. Why? Yes, adsorption of reactant on the solid surface of the catalyst increases the rate of reaction. Okay, adsorption of the reactant on the solid surface increases the rate of reaction. So it is used as heterogeneous catalyst. Okay, next is used for the separation of inert gases. How it is used as separation of inert gases? Yes, the property of noble gas, one of the property of noble gas is used here. If we take a mixture of noble gases and coconut charcoal, you can see that different noble gases adsorb under coconut charcoal at a different temperature. Okay, this property is used for the separation of inert gases from a mixture of noble gases. Okay, and the seventh point is that it is used for as a medicine, as a drug, or curing diseases. How it is used? A number of drugs can adsorb the germs and it helps to remove from our body. So it is used in the curing process, curing diseases. Okay, and the next point is that froth flotation process. You may studied in your 10th standard what is froth flotation in metallurgy. Okay, so the phenomenon of adsorption is used in the froth flotation process. And next is adsorption indicators. Fluorescein, eosin are example. Okay, and another point is that It is used in the lab for the chromatography analysis. Okay, the basic principle is of chromatography analysis is that adsorption. So one of the application of adsorption is that it is used in the chromatography analysis. Okay, these are all the main applications of adsorption. And I think it was a long video, but we are discussing small simple things. Okay, study well. Today we are winding up this video. Thank you.